Hello viewers of our channel. I decided to record another useful video on the repair of laser levels. We have not yet had a video on rotation levels on our channel since they do not get repaired very often. So let's go. I received such a laser rotary level for repair. You can be seen that the device was badly damaged. The glass is broken and the whole mechanism is inside it. It is very skidded. A few words about the laser level. This is a very reliable laser level. From the world famous German company Geo Fennel. And in general, I once started my career in measuring technology with these brands of measuring equipment. It was back in 2010. I work in this company. Once upon a time, Geo Fennel was the leader in measurement technology in Europe. In general, now we disassemble the device. I'll show you how it's set up. There will be questions? Right, ask me please. We work together. I see that the device has already been disassembled. Some screws are missing. Someone must have tried to fix it. Most likely the device was disassembled. Most likely the base was broken there. I think they got scared. The device was collected back and they decided to bring it to us for service. The level is disassembled with an ordinary Phillips screwdriver. I repeat, some screws are missing, some seems to be stripped. So, we remove the top cover. It can be seen that many screws are unvisted, as well as the whole mechanism is skewed. I think it's missing some kind of support pin, or maybe it's broken. Something is really broken on this side. Now we will analyze the device further and try to find the cause of the breakdown. Now we will see each connector, so as not to confuse later. It can also be seen that the board is hanging. Most likely it was simply not inserted into the seats. It is also clear that the device was assembled. The wires were crushed. I think the level was dropped, broken. We decided to try to repair it ourselves, dismounted the device, and they decided to bring the device to me for service. So, I disassembled the device and already saw at least a breakdown. Let's try to fix it now. I want to say a few words about the design of this device. Tell how it works. Show that devices that were produced early were more reliable and easier to maintain and repair. Previously, devices were assembled from separate models, but now almost all rotary levels are made as a monoblock. So, according to the design of this device, this is the base, this is the body, and these are 4 supports. The whole mechanism is attached to these racks. The device has 2 sensors that set the level. This sensor commands the servos through the control board, and the servos align the laser model. The servo drive consists of an electric motor and a set of gears. This is also such a large control board. Separately, a motor is installed that rotates the prism, emitter of the laser model. and actually the laser model itself which gives the laser beams. So everything is simple, clear. The design is easy to maintain and repair. Each individual element can be replaced if damaged. Now, according to the breakdown, the blow was so strong that the support pin is broken there. This pin on one side is twisted into this plate, and the other and rests against the moving part of the servo. Now we will replace this broken pin and see what we will do to repair it. Setting up this device is quite easy. We take the device, go into the calibration menu and use the remote control to set the level we need. Next, save the settings and that's it. See the video description for calibration instruction. There is also a second option, which I went through mainly with Hilti levels, as well as with those levels for which I could not find a service manual. Here, as a laser diode, it is attached with such plate, and this plate is screwed with 3 screws. And here we get such a spherical emphasis. By tightening and releasing these 3 screws, you can adjust the position of the diode beam relative to the emitter prism, and accordingly adjust the plane. That's the laser level project. This procedure is quite laborious, time-consuming. Sometimes you have to disassemble and assemble the device many times. But when there are no other options, then you can configure it in this way. In total, we first eliminate the mechanical failure. Then we assemble and configure it. We change this broken screw, pin, guide, call it whatever you want. The device was repaired, everything works and shows well. The instrument was calibrated with the control panel. The tuning was carried out at a distance of almost 30 meters. It is the radius, or 60-meter diameter. The error turned out to be about 2, maybe 3 millimeters per 30 meters in radius. Also, replace the broken glass. I took the replacement glass from an old non-working scanner. In general, I am satisfied with the results. The device works well, the accuracy is normal. That's all. Thanks for watching and goodbye.